We're going to be looking at Newton's second law here. And so we've already talked about Newton's first law, which just says that things start moving or change how they're moving if they've got a non-zero net force. Newton's second law looks at how that actually works, or what the specific kind of details that come up of those changes in motion. So let's jump on into it here. So Newton's second law, like we said, it describes how forces change the acceleration of an object. Or rather, let me actually say the velocity. It determines the acceleration, but it'd be better to say how they change the velocity, since that connects more closely with Newton's first law. So it describes how forces can change the velocity of an object. And the way that we usually see it depicted is that the net force will equal the mass times acceleration, or sometimes you'll see this notation with sigma f equals ma. And this sigma, again, is just net or sum. So if we have the net force equals the mass times acceleration, really this comes from saying that the acceleration an object experiences is equal to the force, the net force, divided by the mass of that object. And we know that both sides have to match, so in other words, we know that 1 Newton is equal to 1 kilogram meter per second squared, because on the right we'll have kilograms here, meters per second squared from A, and on the left we'll have newtons. So this is the definition of a Newton mathematically. So that's Newton's second law. Let's jump into an example here. A satellite has engines that create a thrust of 10 to the third newtons. If the satellite has a mass of 450 kilograms, what is the maximum acceleration it can achieve? Assume the satellite is far enough away from other objects. The only significant force is the engines. So we're going to start with a free body diagram, because that'll help us just make sure we know everything that's going on. So we have a force, we'll just call it Ft for thrust, is equal to 10 to the third newtons. And we know that we want to start with net force equals mass times acceleration. We can also label on here if we want, m equals 450 kilograms. So we want to solve for acceleration. So acceleration equals net force divided by m. Acceleration equals Ft divided by m. Acceleration is equal to 10 to the third newtons divided by 450 kilograms, which will be 0.22 meters per second squared. Is equal to the maximum A. Obviously, if the thrusters can produce a thrust of up to 10 to the third, they could produce less. So this is our maximum acceleration. Double check our units here real quick. 1 Newton over kilograms is equal to 1 kilogram meter per second squared divided by kilograms. So we see that the units are in fact meters squared. So that's using Newton's second law. Let's look at a slightly more complex example next. 2 dogs are playing with a stuffed animal that weighs 2 kilograms. If one dog pulls the toy to the left with a force of 10 newtons and the other dog pulls the toy to the right with a force of 11 newtons, what is the toy's acceleration? So we'll have force 1 is equal to 10 newtons to the left, and we'll have force 2 is equal to 11 newtons to the right. It's not a perfect diagram, but you get the idea of the one to the right is larger, and we have mass is equal to 2 kilograms. That should say mass. It does not have a weight of 2 kilograms. That doesn't matter a whole lot now, but in the next video you'll see where we talk about weight a bit. Okay, so net force is equal to mass times acceleration. Again, we're solving for A. A is equal to net force divided by mass, which is equal to F2 minus F1 over m, which is 11 newtons minus 10 newtons over 2 kilograms, and that's going to give us 1/2 meter per second squared to the right. Again, we need to include our direction. You'd be okay if you wrote something like this to indicate the directions positive and negative, and then you could just leave this as positive 1/2 meter per second squared. But this shows what our acceleration is, and that's our answer. We know that these need to be subtracted because they're in opposite directions. If you prefer, you could have written them as a sum, but remember that F1 is going to be negative in this example. So it would look something like this. If that's confusing or if you have questions on it, let me know. But otherwise, that'll wrap up Newton's second law here.